All right. As I promised, I would do another section, another episode regarding the palletizing, robotic palletizing. In this one, I would talk about the logic, what is happening basically at the background, and what are the block functions that you need to actually connect the infeeders to the robot and trigger the robot in order to pick up the objects or boxes from the conveyor and put it on the pallet. So we will go deeper and find out what are signals that are needed to be adjusted. So if you come to the simulation tab, you can open the station logic. And in station logic, you can go to the section design. So in the compose, we have now a vacuum, which is our tool, an infeeder, and an outfeeder, right? And of course, there are some other stuff like your pallet or I don't know, some structure, mechanical structure to whatever. It could be anything inside this. But for us, it is a very small or let's say easy version of this palletizing task. So if you go to the design, if you go to the infeeder, I need to define some kind of like digital input for the infeeder. So if you double click on that, you will open this dialog, and in signal and connection, you can find this tab as add IO signals. So if you click on it, you can see that there is a type of signal which we can define, for example, digital input, and then there is a name which we'll call it like digital input underscore sorry look, for example, feed in. So we will call this one, and then description signal value, like a default value, which we'll consider as 0, for example. And the number of signals, it could be a group of signals, but we will consider this as just a binary 0 and 1 signal. So when you click OK, then at the down list, at the down of the list, you will see this DI feed in. So we will add some more digital input, digital DI underscore, let's say box 1, and again DI box 2. These are good signals that you can actually try your code or the performance of your robot with different scenarios, so you can use these signals later. Let's add again DI box number 3, and last digital input DI box number 4. So we have now 4 digital input, or maybe 5, yeah. And then we need to define a digital output, which we can call it as, yeah, digital output cleared box. So what does it mean? It says that the infeeder actually tells the robot that basically my object was taken by robot. So it's kind of giving the robot that I don't have any object. It could be, or you could like consider it as I've got the object and now you can come and pick it up. This could be also what we will see later. What's the meaning of this? So we have created also as well this output. Then if we go back to the station logic, you see that all these basically digital input and digital output are now created. So what we need to do at this time, we need to connect digital output of cleared box to digital input number 10 on the system. I explained later previous video how we can actually from this menu you can find these defined values if you don't see it. I already like this box. And then for gripper or vacuum gripper, you also do the same thing. You go here, you create a digital input, and you will call it like digital input attach with a signal value number 0. And also you will create one digital output with the signal base name as do attached. So what this one is digital output, right? All right, let's go back to the station. So you see that this value is now created. What we need to do is to define when the system identifies or tells to the vacuum that you have attached, and now you need to deattach. So you can, for example, connect digital output number 10 to digital deattach. So basically the robot comes, it's the time exactly. This is the signal that you need to tell, the robot tells to the gripper that the object is there, so attach it to yourself. And another signal that we need is in outfeeder that you need to, or we need to define as well. So we go again to this box or whatever. I hope that I'm actually, just a moment. So this one we could go inside. Then we have basically this one. Why can't go inside that block? That's not good. It looks like a fixed outfitter, which don't understand why I can't actually add more signal. We need to find out why. All right, I guess I know why. Basically there is this problem. If you see that a block that if you double click does not go to the IO list, you need to find that block. For example, this one. When I double click, I open this fix, let's say, window, and from here you can see that this is the selected, right, outfitter 1320. When you right click, there is a properties as disconnect library. If you click on disconnect library, then it will be disconnected from the predefined values by the library. And now if you click on that, then you can go to the signal IO list, and then here you can basically define the things that you need. For example, you can define an IO, which we need basically an IO digital input, DI, palette in as the input, and then we can define as well a digital output. Of course, maybe it's not relevant here, but we will create one. Digital output as palette out. This is the digital output. So we have both of them, right? Good. Now we go back to the station, and we need to connect digital output to digital input palette in to the outfitter. So it means that the system has done, or the robot has picked up the packet and had put on the conveyor. Now it needs the robot needs to tell to the outfitter that I've put the box on the pallet, and you can do we can continue basically. Now after creating the main parts of the blocks, that includes the system, which is basically the robot controller, and also the infeeder, outfeeder, and also the tool, which is our vacuum, basically the vacuum as our tool to pick up this stuff. So then we need to go inside, for example, in the infeeder and define how we can define the logic basically. To do that, you need to double click on the infeeder and go to the design. And in the design, we have to create some logic. Unfortunately, because it was already made, I have to clean up some stuff because they are not basically needed. So I let them zoom out because, as I said, this was a defined block from the library. So I have to clean it up a little bit in order. But I see now digital inputs that I actually defined and one digital output that exists already. So I basically do not need the rest. So let's if we can basically delete all these signals connections. And well, basically we don't need actually all these connections, because what we are going to do is we can just put this somewhere like that. We need to we can right click and make a source. So I need to go a little bit to zoom. Okay, so we have now a source which will define exactly what is our source. Our source here is our infeeder, right? So okay, basically what you need to do after selecting this block, you need to define the source. So this is basically, it says that the box that, or the package that is on the conveyor needs to move, right? So, but I cannot select it from here, the box, because the box itself needs to be as a to be included under the branch of infeeder. So I would like to try this and put it under. So do you want to reposition box? I would say yes. And box, yeah, now it is under infeeder. If I go to the station, yeah. So this could be the starting point for the box, but we will see. So the box is now a child for infeeder because now it is under this child. So if I go back to the simulation station logic infeeder and in design, So when I click on the source, when I come here, the source, I can find box, which is basically, as I said, the child of the infeeder. And you can also define a position of that, but let's consider that the current position is the correct position. And just click apply and closed. So this was basically the first step. And the second step is that we need to connect, let's say, if we trigger digital input as a feed-in, it needs to be executed. And then we need basically to move this thing, right? So we need a linear mover. So we create a linear mover. And in linear mover, you have to connect copy. So a copy from this source, which is our box, and then to move. So object here is the basically a copy of the box. And then you can, like, for example, if you click on it, you can here define the direction. For example, let's say the direction is 0 from the X value, and here you can say, I don't know how long is actually our conveyor, let's say 2000 millimeter, but we can actually first I need to measure the starting point. So I will select one of this value from here to, let's say, here. So almost we have 3 meter in X direction. So probably I need to, but considering the value from the width, I think 2700. Let's measure it again from here until here. Oops, I forgot. From here to here, 2600. So I would like to actually know 2600, and the direction here in y direction is 0. So, and the speed I would say 500 millimeter per second, and the reference is global, and apply. So because, as I said, it seems like it moves actually in the X direction, but we will figure it out if I'm right or wrong. So we will go back to the station, the infeeder. So we have now a linear mover, and then we need to define a logic, or logic SR latch. So it means that when, based on which condition, this copy or whatever of the part can move. So it's a kind of like set and reset. So we will add an logic SR latch, so like that, and put it here. And from execution, it goes to set value, and output also goes to execute. But I need to know, do we need to add anything here? No, just the inverse output is okay. Good. So the first source is created. Then we need to say that, all right, when we trigger the signal, you move the package in X direction, for example, if it's correct. Then when you see the sensor, you need to stop, right? It cannot continuously or indefinite like move. So it needs to stop somewhere. That's the reason that we need to define a plane sensor. So for that, we go to the sensor part, and then we define a plane sensor. And we can bring it here. And the plane sensor, as I said, I click on it. We need to define this position, right? So for that, I need to exactly define that's where this sensor would be located, right? So I will go to the I would like to put my sensor somewhere like that. So I would come here and then select maybe this part. So I will, it's here, and then come and select here. And let's say the axis, I would say 800. And so I need to know exactly where it is now. I actually here maybe. So yeah. So I see some but the sensor is actually in the wrong place. I don't know why. So oops, undo. Why it is now there? That's a big question for me. So 800. Okay, I see something's happening. But I think it's a wrong orientation maybe. So X basically here in Y direction maybe 400, and maybe, okay, so this should be 0 and this should be 400, I guess. All right, so 800 will make it like 200, and then we will increase this one to 600, something like that. So this is the location of our sensor. So it means that when the box comes in this area, it needs to stop, right? It needs to stop. We could define, I don't know, maybe we need to define or change the location or position of the sensor. But so it's like that. You define a point, and then you define it has two axes, X and Y, and then you can play around and make it bigger. For example, I could actually make, in X direction, maybe 300 to make it a little bit bigger to stop. But we will find it out, okay? So this is also the planar sensor to detect the box, all right? Okay. Now that we have our box, maybe guys, we need to define a box position. I don't know. We need to do the simulation and see how it behaves basically. So we have the plane sensor now defined, the origin access sensor for IO port, and from this we need to take one connection out and put it to the reset. So a reset here, it means that when the sensor sees the box, it needs to stop the motor basically. But yeah, this is something probably we need we need to connect not only this guy to the logic as our latch, but also to the output, that basically the box should be cleared, right? So I will as well connect this to I don't understand why I can't connect this to the output. So we have one DO, but it doesn't let me. It lets all, but it doesn't let me this one. Maybe we need to go and find out why. So in the signal connections, we defined something like that, a digital output. And in the IO connection, so we have the IO connections here. So basically it is listed already as the output. But why I can't? That's a question. You don't want to do that read only, of course. Maybe we can create another one and delete this one. Yeah. Maybe if we go here and directly define a digital output with the name as DO clear box, for example, and number of the signal has to be 1. It was probably a bug, so you just need to create this output and just connect this sensor out to the output. The infeeder is now defined. So we need to, from digital output, connect it to digital input, and now the infeeder is all right. Let's go to, so the system is also fine. Now we need to go to the vacuum. So let's go to the vacuum. All right, in the vacuum we have already some defined, but also we defined to one digital input, one digital output. So let's go to the design. In the design, so again, there are some already defined, so we don't need them. I just delete these connections. Can just leave it like this, because as I said, it was a part of the library, so I just copied from the library, but we don't necessarily need to. So we need to define a sensor for the grabber or vacuum grabber. So we put a line laser. let's find the sensors. In the sensors, we define a line sensor. So what is the difference between this line sensor and plane sensor? Of course, a line sensor is just a beam. So the idea is that when the grabber or the vacuum grabber comes and sees that the object is there, just sense it and pick it up. But for the plane, well, basically we could also use a line sensor for the conveyor, but the plane would be better because it has an area. So when the box enters in this area, then it will sense the object. So first we need to double click on that. Let's see what is the first we need to define the, of course, position and the radius, and then okay, it should be active when, of course, sees an object, right? But we can connect this the attach. That's, for example, when the robot is there and says that to the grabber that I'm in the right position. Now you can, if there is anything, you can continue or activate your suction mode. So we need to define how we can define. We can go to the visual graphical interface. I would like actually to put or insert my the position of the thing, the sensor exactly here, right? So then end should be maybe a little bit 1000, the same place. X only in Z direction should be a bit less, 2000 for example. So it looks like that. So the line laser looks like that, but it's actually very enormous big. So 2200 for example. Just one more. So I don't understand why it is actually not straight. So it's not vertical because I didn't change. Okay, maybe I just copy everything from top and then paste, and then this paste. So yeah, now it is completely vertical, and now we have defined the position of our sensor.